We have here on the bench two 308 cartridges. This is a standard brass cartridge. This is our composite cartridge. They're the same length. They use the same projectile. In our military version, the 7.62x51, we use the same powder and the same primer as the military round. And we get the same ballistic performance at the muzzle, so the same velocity with the same projectile. However, that's pretty much where things end. In a brass cartridge, the internal shape or profile very much follows the external profile, while in our case, the external profile is dictated by the chamber. However, the internal shape is dictated by how we mold the part. This allows us to shape the way the powder column burns, and thus the way gases are produced, and then move the projectile down the barrel. We control the molding process very tightly so that the parts are very consistent one to the next. That leads to a very consistent overall round, and that consistency translates to tighter standard deviations on velocity, which will help translate to less dispersion, so i.e. tighter groups on the target. Starting at the muzzle and working backwards, the signature on our round is much less. That indicates a more complete combustion of the powder during the internal event. We run far less powder than is run in the standard round. 8 to 10% less powder in this particular round, but we're producing the same ballistic numbers, which means that we're burning more efficiently. We're getting the same output with less input. Part of that is because we don't transfer heat into the chamber of the weapon. So our polymer case is an insulator as opposed to brass, which is a conductor. So a good portion of the energy created during the internal ballistic event is transferred into the chamber in a normal weapon through conduction of heat through the cartridge case. We transfer far less heat than brass does, and that allows us to either put that energy down barrel, or to maintain the same ballistics at the end of the barrel, we use less powder.